Welcome, investors, to today's Explainer. Look, we're here to talk about what is, without a doubt, the solar system's ultimate untapped frontier. For decades, our capital and focus have been glued to the inner planets and the big gas giants. But today? Today, we're laying out a prospectus for the next massive leap in space exploration. We are talking about the Uranus Flagship Mission. I actually want to grab your attention right out of the gate with just a single number: 1. Think about that. Out of all the billions of dollars, the resources, the decades of spaceflight history we have, exactly one spacecraft has ever visited this massive market opportunity. We are looking at a severe data drought here. And, as we all know, where there's a drought of data, there is a massive, massive opportunity for discovery. So, ladies and gentlemen of the board, here's how today's prospectus breaks down. We've got 5 key areas. First, the ultimate untapped market. Second, the 1986 data drought. Then, mysteries yielding high dividends. Fourth, the flagship mission solution. And finally, execution and launch timeline. All right, let's jump straight into Section 1, the ultimate untapped market, and really understand the asset. What exactly makes Uranus worth our investment? Well, here is exactly what you're buying into. Unlike the gas giants Jupiter and Saturn, which, are mostly just hydrogen and helium, Uranus is an exotic ice giant. We're talking 80% or more of its mass being made up of this hot, dense fluid of icy materials, specifically water, methane, and ammonia, all just swirling above this relatively small rocky core. It's a totally different class of planetary asset. But what makes this asset absolutely truly unique is the sheer volume of physical anomalies. It is a scientific gold mine. Just take a look at that 97.77-degree axial tilt. The planet literally spins on its side. It rolls around the sun like a giant barrel. And then add in these violently extreme wind speeds. We're talking up to 560 miles per hour. You've got retrograde winds at the equator actually blowing backwards against the planet's rotation, while the polar winds blow forwards or prograde. The physics at play here literally defy our standard planetary models. And trust me, the anomalies absolutely do not stop at the surface. Uranus has a magnetosphere unlike anything else we've ever seen. Its magnetic field is offset by a full third of the planet's radius, and it's tilted 60 degrees away from the axis of rotation. So what does that do? It creates this bizarre, twisted, corkscrew-shaped magnetotail trailing behind it. In fact, just recently, the James Webb Space Telescope mapped these highly complex auroras sweeping right across the planet's surface because of this crazy magnetic structure. It's just an unparalleled research opportunity. Okay, moving right along to Section 2, the 1986 data drought. Let's look at the gap in the market here, because this represents a major, major hole in our current portfolio: the severe lack of modern data. Just look at the shocking disparity in our planetary investments. We've sent dozens of orbiters and rovers to Mars, right? We have continuous high-definition data streaming back from Jupiter on the regular. But Uranus? It's the third largest planet in our solar system, and it has received exactly 1 flyby and 0 orbiters. 0. We have absolutely no continuous attention on this asset. So the crucial point here is that our entire baseline for Uranus comes from a single, very brief flyby by Voyager 2, way back in January 1986. Now, don't get me wrong, that mission was incredibly successful. It discovered 10 new moons, it found 2 new dark rings, and it recorded a mind-numbing minus 214.2 degrees Celsius atmosphere. But it only spent a matter of hours at its closest approach. Hours! It just barely scratched the surface of what is actually out there. And that brings us directly to Section 3, mysteries yielding high dividends. This is the value proposition. These are the mysteries that a dedicated mission is finally going to solve, yielding massive scientific returns. For instance, here is one of the most glaring questions in all of planetary science. Unlike the other giant planets, Uranus's internal thermal emission is practically 0. But why? Was there some massive primordial impact early on that basically expelled all of its heat? Or, as some recent studies have suggested, is there a layer of dissolved magnesium acting like a giant thermal blanket, trapping the core's heat and preventing it from escaping? Solving this would literally rewrite our understanding of planetary physics.
The scientific return on investment here is phenomenal. Beyond the heat mystery, we really need to understand its erratic cloud formations and finally map its deep atmospheric circulation. We need to conclusively find the origin of that crazy sideways tilt. And, okay, this is perhaps the most exciting part for you astrobiology investors. We desperately need to investigate its moons, specifically Ariel and Miranda. Voyager 2 showed us surfaces covered in deep canyons and impact craters, hinting at past geologic activity that strongly suggests these might actually be hidden ocean worlds. And the implications of all this, they go way, way beyond our own neighborhood. Astronomical surveys have confirmed that ice giants are actually an incredibly common type of exoplanet out there in the wider universe. So, understanding our own local ice giant is the absolute key to characterizing the thousands of giant planets we're discovering far beyond our solar system. Uranus is essentially our cosmic Rosetta Stone.
So, how do we fix this? Enter Section 4, the Flagship Mission Solution. Let's talk about the product that's going to deliver these high-dividend answers. Now, we've seen concepts like Horus, Europe's Muse, and the new Frontiers-class Oceanus float through the pipeline over the last decade. They're good concepts, but one concept really stands out from the pack as the ultimate comprehensive flagship asset. We are pitching the Uranus Orbiter and Probe, or UOP. Listen, this isn't some quick flyby. This is a massive, top-tier, 7,235-kilogram flagship spacecraft. It's custom designed to spend 4.5 years actively orbiting and entirely dominating the Uranian system, giving us a continuous, high-value stream of data. The execution of this product relies on a brilliant two-pronged approach. First up, the main orbiter is going to conduct multiple flybys of the major moons, map the rings, and navigate that crazy corkscrew magnetosphere. Second, it's actually going to deploy a dedicated atmospheric probe, dropping it right into the Uranian weather layer. It perfectly pairs long-term orbital mapping with direct in-situ atmospheric sampling. Let's move to our final hurdle in Section 5, Execution and Launch Timeline. Let's discuss the window of opportunity, the execution strategy, and frankly, the extreme urgency of our schedule. Getting a 7,000-kilogram asset to the outer solar system, yeah, it is no small feat. It requires a grueling 13.4-year cruise. A launch in the early 2030s requires a gravity assist from Earth, and it's heavily reliant on a very specific gravity assist from Jupiter in 2035 just to fling it toward its final arrival at Uranus in 2044. So we need to build some serious urgency here, investors. Optimal Jupiter alignment launch windows exist specifically between 2030 and 2034. If we miss these specific windows, and it is a risk, recent planetary plutonium shortages might push operations into the late 2030s, but if we miss them, the trip becomes significantly harder. We're talking longer transit times or way heavier launch vehicles. The time to commit capital and resources is right now. And hey, you don't just have to take our word for it. The scientific community has spoken. The 2023 to 2032 Planetary Science Decadal Survey, which is literally the consensus of the entire global scientific community, officially ranks the Uranus Orbiter and Probe as the absolute #1 priority for a new NASA flagship mission. They put it ahead of missions to Mars and Enceladus. The scientific community is screaming for this data. So I'll leave you with this final thought. We have a planet spinning on its side, encircled by hidden ocean worlds, holding the literal keys to understanding thousands of exoplanets across the galaxy. We've got the technology, we have the plan, and we have the scientific mandate. Investors, the window is closing. Are you ready to fund the future of solar system exploration and finally unlock the ice giant secrets?